All right, so here's the test review for the Conics mid-unit review. These ones just say to find this information and graph it. All right, so let's see. So first off, remember H is with X and K is with Y, so this is H and this is K, and we got to recall that that is 4P, right? So when we're writing the vertex, we take the opposites. The opposite of -3 is 3, and the opposite of 6 is -6. I'm going to go ahead and plot that. All right, now X is squared, so my possibilities are up and down. 4P is positive, so my graph is going to open up. All right, so this is my vertex here. Right here, we're going to take 4P and set it equal to the 4P value, which is 16. Divide both sides by 4, and P equals to 4. So we go 4 units, the focus is 4 units above. And the directrix is 4 units below. 1, 2, 3, 4, and that's a line. So my focus is 1, 2, 3, -2. And the equation of my directrix is y equals, let's see, 7, 8, 9, -10. Y equals -10. Axis symmetry is passed through the focus and directrix. And x equals 3. And the number of units on each side, you just take the absolute value of 16 and you divide that by 2, which is 8 units. So go to the focus, we count 8 to the right, 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. And we start from our vertex, connect those dots, and make our graph. And there's the first one there. All right, for the next one, make sure you take a look to see where H and K are located. Remember, H is with X, K is with Y. So this one's backwards, so remember, opposite signs, so that's 1, comma, -4. 1, 2, 3, 4. We see that Y is squared and 4P is positive, so that's gonna open to the right. So we're going to take 4P, set it equal to 12, because that's what it is, and P is equal to 3. So 3 units to the right, and 3 units to the left. 1, 2, 3, and that's my directrix right there. So we have, let's see, we have 1, 2, 3, 4, -4 for my focus. And my directrix is x equals -2. Axis symmetry passes through the vertex and the focus. So right here we have y equals -4. And the number of units on each side, we're going to go ahead and take the absolute value of 4P and divide that by 2, which is 6 units. So go to the focus, 6 units down and up. 6, and start from our vertex, connect those points to make our graph. All right, and there's my graph for the second one. All right, for the third one, again, just make sure you know where H and K are. So opposites, 1 and 5. This time it's negative, so it's going down. And let's see, vertex here. So 4P equals -8, and P equals -2, but I'm just going to talk about 2. Remember, focus is below it. So we see the focus is 2 units below. And we see the directrix is 2 units above, and that is a horizontal line. So the coordinates of my focus are 1 and 3. And the equation of my directrix is, let's see, 5, 6, 7, so y equals 7. The axis symmetry passes through the focus and vertex, which is going to be x equals 1. And the number of units on each side, the absolute value of -8 divided by 2, so 8 divided by 2 is 4. Let's go to your focus, count 4 to the left, and then 4 to the right. Well, that was right and then left. Start from your vertex and make your graph. And there we go. All right, for the next one. Again, careful where H and K are located. So this is K, this is H, so opposite signs. So 1, 2, 3, 1, 2, And this one, it's left because it's negative and y is squared. All right, so 4p equals -4, so p equals -1 or just 1. So we have 1 to the right and 1 to the left. Directrix, focus, this is my vertex. So we have -4, 2 for the coordinates of the focus, and x equals -2 for the directrix. For my axis of symmetry, y equals to 2. And number of units on each side, the absolute value of -4 divided by 2. So 4 divided by 2 is 2. So for my focus, 2 points up, 2 points down. And there is my graph. All right, for 5 and 6, we're going to plot the information, and we're going to come up with the equation. So write an equation for a parabola that contains the following. So focus is at 5, 0, 1, 2, 3, 4, 5. Directrix is x equals 1. So we know the vertex is in the middle, so I count the distance, 1, 2, 3, 4, half of 4 is 2. So I know my vertex is at 2, 0. Let's put that here. Vertex is 2, 0. The p-value, it's opening to the right 2 units, that's +2. And since it's opening to the right, here is my equation. So we just plug these numbers in. So k is 0, so I don't really need to put it, I just put y squared. 4 times p, 4 times 2 is 8. X minus h is 2, and there's my equation. And in case you're curious, it does open to the right. All right, for the next one, let's go ahead and plot this. So -3 and 1, that's my focus. And y equals to 3, 1, 2, 3, and there's my directrix. Again, we know the vertex is in the middle, and here we can see the graph is opening down. So my vertex here is going to be -3, +2. And my p-value is 1, but it's -1 since the graph is opening down. So for this one, we know the equation is x minus h squared equals 4p y minus k. All right, so parentheses, x minus, when we take h and plug it in, it becomes positive, so the sign switches. 4 times p, so 4 times -1 is -4. Y minus k is 2, so it becomes y minus 2. All right, for the next one, same thing, except this time I'm giving you the graph, and you have to figure out the rest. So for this one, vertex right here, let's see. So be careful that you identify the x and y axis. So here we can see that it's 0, 3, or sorry, 0, 2 for the vertex. Graph is opening down, so the p-value is -2. Again, we're going to use this equation right here. So we have x minus 0, so that's just going to be x squared, equals 4 times p. 4 times -2 is -8. And then y minus k, so y minus 2. All right, for this next one, again, let's just make sure we understand where the x and y axis is here. So this is the x-axis, this is the y-axis. So this one appears the vertex to be at the origin, so 0, 0. We can see it's 2 units to the left, so that's -2. And now we use this equation here because it's going to the left. So our k value is 0, so just y squared equals -2 times 4, so 4 times -2 is -8, and x minus 0, which just becomes x. So y squared equals -8x. All right, let's go on to the back now. All right, so these are the modeling the quadratics, so you're going to have to write the equation for each one, and you can see the forms are given to you. So for this first one here, let's just identify where h and k are in x and y. So this is h, the vertex is hk, and the point is xy. So we're going to plug these numbers into here. So y is 4 equals a, x is 2 minus h. When we plug that in, it becomes +2 squared minus 5. 2 squared is 4. Sorry, 2 plus 2 is 4. Sorry about that. 4 squared is 16. 16 times a is 16a. And we're going to go ahead and add the 5 over to the other side. And this gives me 9 is equal to 16a. divide both sides by 16, and we get a equals 9 over 16. Now let's write my equation. I start with y equals, a is 9 over 16, parentheses, x minus h, so plus 2 squared, and then k is minus 5. And there's my equation. All right, on to number 10. And again, we're going to identify where, let's see, so vertex HK, point is x, y, and let's go ahead and plug these numbers in. So we have y equals, so negative 5 equals, a times x is 4, minus h is 2, squared, plus k, and that's a positive 1, so plus 1. So let's simplify this. Negative 5 equals a times 4 minus 2 is 2. 2 squared is 4, so 4 times a is 4a. Let's go ahead and subtract this one over. So we get negative 6 equals to 4a. So let's write this over here. And to solve for a, we divide both sides by 4. And we get a equals negative 3 halves. So my equation would become y equals negative 3 halves, parentheses, x minus 2 squared, and that's a positive 1, so plus 1. And there's my equation. All right, on to the next one. Here, this is intercept form. So this time we need to identify P and Q and X and Y. So intercepts are 3, 7, so P and Q, and this would be X and Y. Now we're gonna plug them into this formula. So Y is 2, A, X is 4, so 4 minus 3, and then again, X minus, so 4 minus Q. And now we're gonna just simplify it here. So 2 equals A, 4 minus 3 is 1. 4 minus 7 is negative 3. 2 equals, negative 3 times 1 is negative 3, times A is negative 3A. And then we're going to divide both sides by negative 3. And we come up with that A is equal to negative 2/3. For my equation, when I plug things in, always make sure you should have y and x visible, like they should be in your equation. Y equals A is negative 2/3, x minus 3, x minus 7. And remember, the order of 3 and 7 doesn't matter. All right, let's try this next one here. Okay, again, we're going to identify the x-intercepts, P and Q, and point is x and y. So let's go ahead and write this equation with these plugged in. So y is 8. A times x is negative 4 minus, my first one is negative 2, so when I plug it in, it becomes positive 2. Negative 4 minus q is 5. All right, let's simplify it. Negative 4 plus 2 is negative 2. Negative 4 minus 5 is negative 9. 8 equals, negative 9 times negative 2 is 18. 18 times a is 18a. We're going to divide both sides by 18. And a is going to be equal to 8 over 18 can reduce to 4 over 9. So then my equation becomes y equals 4/9 for a, x minus, when we plug in the negative 2, it becomes positive 2, x minus 5. And there's my equation. All right, for number 13, let's go ahead and do the calculator. So open up a new document. We're going to do add a calculator, menu, 6 for stat calculation, 1 for one variable statistics, and 6 right there for quadratic regression. All right, don't forget control, close parentheses to open up your braces. Let's type in the x value, so 1, 3, negative 1. Arrow down, and then we'll put those braces again for the y list, so negative 1, negative 7, negative 11. So make sure we have it 1, 3, negative 1, negative 1, negative 7, negative 11. Hit enter twice, and there we go. And we see r squared says that it is a quadratic function because that's a 1. So now let's just plug our numbers in. So we have y equals, a is negative 2, so negative 2x squared, plus b, so plus 5x, plus c, but c is a negative 4, so minus 4. All right, and then last we have actually number 14, but I put number 15. Sorry about that. So it says a pumpkin is catapulted in the air at different angles to test which angle is best for launching the pumpkin, the farthest. The table below shows the distance the pumpkin travels at different launch angles. Okay, so here, again, we're going to regress it. We don't save that. Add a calculator, menu, 616. So let's put our x values first. So 20, 30, 40, 50, 60, 70. So 20, 30, 40, 50, 60, 70. Let's put in our y values. So we have 372, 462, 509, 501, 509, 501, 437, and then we have 323. Let's hit enter twice. And there's our equation. Okay, so the first question says to write an equation for the distance of the pumpkin in respect to the angles. So y equals, I'm going to put all these numbers, negative 0.26214, negative 0.261429, x squared, plus bx, which is 22.5914x, plus 23.0286. All right, there's my equation. Part B says predict the angle that would give a distance of 0. So we're trying to find that x-intercept. Okay, so from here, to get to the graph, we're going to do control doc. We're going to go down to add a graph number 2. So it pops up, and notice it starts at F2. We're going to arrow up to get to F1, hit enter, and now our graph is there. So don't forget to hit enter. All right, so I'm going to adjust my window so I can actually see it better. So over here, the highest value is 509. And this goes to 70, so let's see what we can do here. So what I'm gonna do is, I'm gonna change this to around 550. So 509, 550. So let's see if we can see the vertex, something like that. All right, I'm gonna move this out of the way because this just seems to be in the way here. All right, and let's go to this value over here. And so right here, it was about 40, this goes to 70. Let's just put 80 and see what we can do there. I'll just probably put 100 so I see if I can fit it all in there. Okay, there it is. There's the graph. All right, let's see if we can move this out of the way. So up here, I can get this out of the way here. Let's see if we can. There we go. That's good enough. Okay, so now it's out of the way. So right here it says we're trying to find our x-intercept, right? So another name for that is going to be your zero, your roots, your solution. So let's go for 0. And that's going to be menu 6, 1. There you go. See the 0 says, so menu 6, 1. So I'll put that right here so you can see it. So you want to do menu 6, 1. All right, now once you do that, the little line pops up. Make sure it's either to the left or the right of the root. Click down, slide over. When it says 0, you click down again. And we can see the angle is, the angle is 87.4 degrees. So if you want to get the angle that gives you the distance, 87.4 degrees. Okay. Now, letter C says, what is the maximum distance the pumpkin can reach? So maximum is that vertex, right? So right here, we can do menu 6, and we can see the word maximum right there. So we hit enter. And then we're going to go to the word we think the vertex is. So I just usually go left, right. I click down and I slide till it says the word maximum, and the dot stops. So right here, if you notice, the dot is kind of moving. So I don't click it. Even though it says maximum, I wait for the dot to stop. And the dot stopped right there already, so I can click down. And here I can see that the maximum height is the y value of the vertex, so that's going to be 511 feet. The way I did this was menu 6, and I think it was 3. Menu 6, yeah, it was menu 6, 3 for the maximum. All right, next one. Find the distance of the pumpkin when the angle launch is 67 degrees, okay? So for this one here, this is where you do menu 5, 1. So when you're trying to find a y value and you got the x value, you do menu 5, 1. And it said the angle was 67, so I'm just going to type in the number 67, and it's going to say x equals So x equals 67. When I hit enter, it's going to take me directly to that point. And right here, we see at 67 degrees, it is 363 feet. All right, and then once I do that, I do need to get out of it, so I just press escape, and I read the next question. Find the angle of the pumpkin if the distance traveled was 397 feet. So this is a y value, so y equals 397. And notice we put two blanks here because there's two parts where the angle would reach 397 feet. Okay, so here we're gonna go tab. Then we're gonna type in whatever y equals. In this case, y was 397 feet, so 397, hit enter. And then to find our roots, we're gonna do menu 6, 7. We're gonna do that twice because we're gonna try to find these, these intersections. So menu, I said 7, sorry, menu 6, 4. Sorry about that. So menu 6, 4. And there you can see the word intersection. All right, let's go to the left side first. So I'm gonna go to the left intersection, click down, slide over, there's the word intersection. And so my first angle is 22.3 degrees. It'll hit 397 feet. So 22.3 degrees. And for my next one, we're gonna do menu 6, 4 again. And we'll go to the left side, or the right side, sorry. So I'm gonna scroll over, there it is. All right, and let's kind of grab this and see if we can move that out of the way. And hopefully there you can see that it says at 64.1 degrees, you'll be at 397 feet. And that completes the review.